Okay, this is the solving exponential equations, but that have two different bases. But solving two different bases that are not able to be made the same using exponent rules. So remember when we had something like 2 to the x equals 16, I still can use the rules that we just learned in the last lesson. I could hit this with a log base too. It'll work to both sides. I could also change 16, right, to 2 to the fourth power, which should be a little bit faster, no calculators needed, so forth, and then I find out that x equals 4. So a lot of these rules can be applied at multiple times, but yet we have other rules that we should hopefully recognize first, and that's why we did them first, is that makes it faster, which then for most of us says, hey, that's easier, and so therefore we get it done in a timely manner. So today I got a 4-step process here, and so we are going to take the log of both sides, aka hit it with a log. Today you're going to say, wait a minute, they both have, so if you look in both my examples here, they both have a base that's different, and they have exponents. Now notice as well that I cannot make a 3 and a 5 become the same base. So that's very important for this particular lesson. So how do we accomplish this? We accomplish this by saying, hey, you're going to take the log with the base of the most complicated exponent. So if I'm looking here, is 2 plus x or x more complicated? Well, there's more things in the 2 plus x. So therefore, I will get rid of the 3 as a base. Now, it does actually not matter. You can choose whatever log you want. I would prefer that you get rid of the one that's more complicated. But you don't have to, because if you look at the next one, the next example over here, they're both fairly complicated, the same. So there's ways to do this without even having to worry about step number 1. So you still need to take the log of both sides. I am going to take log base 3 of both sides. That means this log will cancel out and I'll be left with an x plus 2. That's why I chose the more complicated side, because that exponent is the answer when I take the log, or that simplifies, we'll say, to the 2 plus x. On the other side, though, it becomes log base 3 of 5 to the x. You have to use your exponent rules. Or not your exponent rules, wow, our log rules. That means I can take that power, that x, that 5, and I can move it out front. So I'm keeping the left-hand side the same. I'm going to drop down the x, so it's x times log base 3 of 5. And now I'll have to use change of base, because I have 2 plus x over here, and this log base 3 of 5 is really a number. 3 to what power is equal to 5? So it's 1 point something. And therefore you'll have 1 point something x's, because that log base 3 of 5 becomes a number. And so if I take my calculator, I get the left-hand side to be the same. I end up with 1.46 x, because log base 3 of 5 is 1.46. And on. So I rounded it to 2 decimal places. Now I have x's on both sides. This is just a algebra 1 style problem. A single x is smaller than 1.46 x's, so 2 equals 0.46x. So if I take 2 divided by 0.46, I end up with 4.35 is equal to x. And of course, I forgot to state this in the last video. I just assumed, and we should always be checking our problems. So even a step 5, check your answers just to make sure. I'm going to leave that for you guys to do, just to kind of verify that I'm doing it right, and then let me know I'm doing it wrong. It's always fun to correct a teacher, right? So the last problem, as we have here, you can see that both of these exponents are pretty fuzzy. There are actually lots of stuff going on. And I mean, those are fairly still simple. I mean, you could have quadratics up there. You could have a whole multitude of things up there. So what we're going to do is we're just going to choose. So in this case, I'm just going to get rid of the left-hand side. I'm going to choose, let's do log of 4 to both sides. If I do log of 4 to both sides, I get 2x minus 1. Yes, that's awesome. Over here, I'll have log base 4 of 3 to the 2x plus 3. And so it looks a lot like the problem that we just did, but this exponent is not just an x now, it's a 2x plus 3, and that 2x plus 3, using the third law of logs, has to be dropped out front. And so that's what makes this a little bit more complicated, is that this whole entire exponent gets dropped. Make sure to use parentheses, please, because you still have a log base 3 of, or 4, log base 4 of 3 on the outside. And if you guys remember, that is just a number. So when I put this on a calculator using change of base, I end up with 0.79. So now I get 2x minus 1 equals 2x plus 3 times, I don't mean, you wouldn't necessarily, we'll use parentheses here, 0.79. And now this, again, is more of an advanced Algebra 1 type problem, is that 0.79 is on the outside of a parentheses. You need to distribute it in. So 2x minus 1. Notice how nice this column was? Because of me choosing to get rid of this particular base, I was able to drop the exponent in its nice entirety, versus the other side, I still left with a change of base, which turns into decimals, and it's just not so nice. And so 2 times 0.79 is equal to 1.58x plus 3 times 0.79 is 2.37. Again, now it's actually a little bit easier. So now that we got them all kind of situated, I'm going to subtract 1.58x from both sides. And so 2 minus 1.58 is 0.42x. So these are gone. And then I'm going to add 1, so it equals 3.37. And so 3.37, divide that by 0.42. And so x is going to equal, divide that by 0.42, equals 8.02. So these numbers are going to be kind of wonky, right? They're not our usual nice, neat 1, 2, 3, 4s. And we've been trying to get away from that in this book in general throughout the whole entire year. So it's not always nice and easy. So your homework for tonight is that another joke worksheet that has both a mix from what we did in the last video with solving when you just have to use a single log, with a single one side basically, but you do it to both sides. And then this time where the bases are the same and they both have exponents that are different. So make sure you follow that. Make sure you ask questions, and we will be, I think, almost done, if not done, with the logs. Awesome. Have a great day.